So hi guys, you are welcome to another video of mine. This is the physics numerical question chapter wise electricity part 3. I'm engineer AD and this is Mosdi Academy. As usual, we are going to be taking 10 questions in this series, which I'm going to be providing solutions to. And as well, you are always free to drop comments and write us mail if you have any questions or any queries about what we are doing. Let it be known to all students that this is just a pre-practice question for all type of our examination, be it WAEC, NECO, GCE, IGNB, JUPEB, and Cambridge exam. So we are trying to make it chapter-wise. We have all chapters in physics and as well as chemistry for now. So it is always available. You can join some of our other channels on Telegram or Facebook, WhatsApp, and other social stuffs. So we are going to get started with this. And the first question we have before us is question 1 says electric cell, that is a battery, has an internal resistance of 2 ohms. A current of 0.5 ohms ampere is found to flow when a resistor of 5 ohms resistance is connected across it. What is the electromotive force of the cell? Fine. Having said that, we have discussed about that before, and we have different ways and different methods we use to write formulas for electromotive force. Like I do tell you guys, it all depends on the nature of the question and the parameters that is given in the question. Now, if you watch carefully, you are going to see here that what is best fit for this is the simplest formula you call your electromotive force formula, which is written in the form of electromotive force is equals to, you have IR plus R. I think it is better in this way, you write V plus IR. V, which you call terminal potential difference, which we have discussed in our concept video class. So directly substituting this, we can say electromotive force is equals to, they say I current flowing here is, we have the parameters are given. If you want me to highlight them, the current here is 0.5. The internal resistance is small letter r, and the external resistance, we call resistance, is 5. So directly, you can just plug in those parameters. And if you do that, this is what you're going to have. You have a 0.5, open bracket, or you have a big R is 5 plus 2. So do the rest with your calculator, and directly, this is going to give you 5 plus 2 is 7. Then 7 times 0.5 is 3.5 foot, which will be the answer to that, which I believe every one of us can do. So that is the answer to the first question. We'll go to the second one. About the second question, we have calculate the terminal potential difference across a 20 ohm resistor connected to a battery of EMF 15 volts and internal resistance of 5 volts. So directly you can as well bring out the parameters so that you know what to substitute. Like I said, the terminal potential difference is given as V. It's still the same formula, which is IR, the same thing as E minus IR. So this is just what we call terminal PD is V, which is always E minus IR. When the cell is discharging, the cell can be short-circuited, the cell can also be charging. All this has been talked about, but this is just problem-solving class. And what we are doing is just to focus on the problems and solve with direct formula, if applicable. And doing so, we are trying to do all this. Now, here in this question, we have the PD, which is, okay, we are looking for the terminal PD. We have the big R, which is 20 ohm. Now, to write that in this format, I know V equals to IR, and directly I can just try and make this formula in another way, such that I'm going to remove what I. Remember, from Ohm's law, I is equals to V over R. So which is the same thing as this. So if I'm trying to do that, sorry, excuse me, I'm going to have V is the same thing as saying E capital letter R over R plus R. It's also a direct formula you can also keep in mind, which was actually carved or extracted from that formula. Substitute this there, collect like times, you're going to see how I come about it. It's quite simple if you understand. Or basically from here, it's direct here. You can say I is V over R cross multiply, you have your formula. But this is also part of the formula we have listed in the word concept video. So directly we substitute V value will be equals to electromotive force given in the question is 15. We are dividing it by, we are multiplying it by the sum of the product of the resistance is 20. So we are now dividing by the addition of 20 plus 5, which is going to give us 25. So doing this directly is what you can do. This by saying 300 divided by 25. I think this should give us 12 volts, which is the question answer for these two. So that's that about that. Then we move to the next question. About the next question, we have fine. This is question number 3. And about question number 3, we have in a given circuit, we have a given circuit of the figure above. You can see this figure. The cell P has an EMF of 1.5 volts and an internal resistance R, should be a small letter R, while cell Q has an EMF of 2 volts and an internal resistance of 10 ohms. If the ammeter read 50 milliamps, then small letter R is dash. Let's take it again. Given circuit of the figure, the cell P has an EMF of 1.5 volts and an unknown internal resistance R, while the circuit has an EMF of 2 volts and an internal resistance of 10. If the ammeter reads 50 MA, then R is equals to dash. So let's do that question 3 solution. We have it here. Now, the first thing we need to check is the way this is being connected. Look at the battery. This is the positive, this is the negative. This is the negative, this is the positive. We've talked about the conventional method of the flow of charge, of the flow of battery. So when you have battery connected like this, what we call the overall or the sum total, we call the effective EMF or the sum total of EMF, which I call ET, will be 2 minus 1.5. You know the reason why is because we are connecting positive terminal with negative terminal, and the other type, it is reverse. So it is always the value of the higher one minus the lower one. If they are connected in the same manner, we add. So please keep that in mind. So effective EMF is 2 minus 1.5, which is basically 4.5 volts. Now, the next thing is we have to get the total internal resistance. Always keep it at the back of your mind that internal resistance is always connected in series with the cell or with the circuit, anyhow you want to say it. So here we have the internal resistance R for the two cells. We're talking about the total internal resistance for the first one and as well as the second one. So quickly, we can just say we are having the two. The first one was unknown. Let me call that X. And the second one was given to be Y, the internal resistance R of 2 volt and internal resistance of 10 ohms. I suspect this is 1.0 because in the labeling here, this is it. 2 as this is 1 ohm. So we can write it as X plus 1 in ohms. So now we can now move. Now the next is the external resistance, or what we call the resistance R total. They are both connected to it's 7. Well, this is only 7. Please, I'm just trying to read across to avoid mistake. That is 7. And the last one, the last parameter given here is the current. The ammeter, which is the current, is reading 50 milliamps, which you can convert to amps. That's 0.05 amps. So directly, my dear students, what we just need is just to substitute our formula, which we have studied. And from what we have studied, we said the current I is equals to the E over R plus R. Or you write it as E equals to V plus IR. Anyhow you want to write it. What matters is you are looking for the value of S. Substitute that parameter and make something a formula. You are going to have something like this. Here we have I here is 50 MB, that's 0.05. I am substituting directly is equals to, we have E here is 0.5. We are taking R plus R. This is 7 plus X plus 1. That is 8 plus X. Directly, you can cross multiply. And if you do that, what you're going to have is something like 0.5. You are opening the brackets, 0.05, open bracket, 8 plus X. So what you do now is just 0.5, which I believe you can finish. This is going to give you 0.4 plus 0.05x. So directly, this move to the LHS, and if you do that correctly, this will be 0.1 is equals to 0.05x. The rest is what x will be equals to. You divide 0.1 divided by 0.05, and you're going to have 2 ohms, because you are writing internal resistance. So that is that about question 3. We talk about question 4, which is also directly under this. About question 4, we have a cell of EMF 2 volts. I think questions are on terminal PD, and internal resistance is 0.1 ohms. It's connected to a 3.9 ohms external resistance. What will be the PD across the terminal of the group? Fine. So if it is connected across it, we can say the terminal PD, which we call V, terminal PD is called the potential difference. It's given by formula already discussed. V is equals to E minus I small letter r. So directly we can go by substitution. The electromotive force given the question is 2. We are taking the subtraction of 2 minus IR is the current IR. I have fine. Okay, we have R. We don't have I here. Very good. We have the question is giving us internal resistance of 0.1 ohms, and we have external resistance of 3.9 volts. We are calculating the terminal PD. Okay, fine. What I'll just do now is just reconstructing this. Remember, I is equals to V over R. So just like what I did in the second stuff, if you remember. So I think I can directly use that in the second question. I use V is equals to ER, remember this, over R plus R, which I think is very better, is the best. So directly we can just substitute E to be 2 times big R was given to be 3.9. We are dividing all this value by R plus R, 3.9 plus 1. I hope students understand this. So you can also substitute I is V by R, and V is still V. Continue solving, then you still get the answer. Bring V to the other side and solve your question. You have a definite answer. So, but this is better if you know how to put it in terms of ER and R and small letter r. So directly now we have 3.9 times 2 is 7.8. We are dividing 7.8 divided by, this is 3.9 plus 1. So we have 1.0, that is 4.9. So now we are talking about 7.8 divided by 4.9. Directly, we can use calculator, which I'm trying to use here. 7.8 divided by 4.9. And we are going to have 1.59 volts as the terminal potential difference. So I hope you understand this. And these are ways to solve questions related to this type of topic. Now, the next one is on the next page is question 5. And about question 5, we have this. Fine. Now, question 5 is asking us to for driving a current of 3 amps in 5 minutes. For driving a current of 3 amps in 5 minutes in an electric circuit, 900 joules of work is to be done. Find the electromotive force of the source in the circuit. We've also discussed, this is question 5. I think this should be question 5. Yes, fine. Question 5. Now, we've also discussed that we can also define electromotive force in terms of work done. There's the work done in moving a charge throughout or from one point to another throughout the whole circuit. So we can say electromotive force, remember, we remember the famous formula W is equals to Q multiplied by E. Basically, you might know it as W equals to QV. So directly you can say the electromotive force is equals to the work done divided by quantity of charge. So directly in this question, we are given the work done here as 900 joules. The quantity of charge, everybody knows, is current times time. Current is 3. The time is 5 minutes. I'm going to say 5 times 60. Everybody knows that. So here directly, we can assume that you can punch your calculator and get the answer. But if not, we can also go by this. We can know that 3 can go here 1, 3 can go here 30. And you know 6 can go in 35. And if you do that, you can see it will cut again, and answer will be 1. 6 here, 1, 6 here, 5, 5 take away 5. What I'm saying is that 60 times 15 is also 900. And this is going to give you 1.0 volts, which will be the question answer. So keep that at the back of your mind. Sometimes question can be very, very simple. And that is an example of what you want. So question 6. About question 6, we have find the equivalent resistance between A and B for the following network of resistors. Fine. So to do this directly, we have to rearrange. And again, we have to remember our short way of getting this, which we say the line of symmetry. Remember, line of symmetry will have or do have same potential difference. So I think this is what we are to know in this type of circuiting. So the first step is just to bring the line of symmetry. I'm doing that on another color. I think will be better. So if I place my line of symmetry here, then I'm going to chop up some values, which you can see. So chopping up some value means they will not take part in what I want to calculate. So which will still make it correct. Now, then I'm going to fold it. These are what I have done in concept video. So if I fold that, my dear student, what I'm going to have here is going to be something like this. Then the quick way to understand all this stuff. This is standing as 1 ohm. These and these are now in parallel. We've talked about this. So if these and these are in parallel, I'm going to have something like, I can give you a rough sketch, something like this. You can see the movement. This is the 1 ohm. Then I have coming like this. Then I have this 2 ohms connected with another 2 ohms. This is 2. This is 2, which we have discussed time and time again, going like this. I hope you can see that. So then I have something like this. I'm trying to show you, this is not part of it as chopped off. So this 1 and 1 is also following the symmetry. It's going to be 1 like this. Then the other one is coming, this one here. It'll also be just like what you have drawn in this way. You have another 1 ohm, which is coming like that. Then finally, they are now connected to the other part, which 2 and 2 are also in parallel. So what I'm trying to say now is that we start from this first one, the 1 ohm, then the 2 ohms. When you try to get the combination of 2 ohm resistors, it's going to give you 1. Shortcut, when they are equal, just divide by the number. How many are they? 2. 2 divided by 2, 1. Old way, traditional method, we use, we say it should be 2 times 2 over 2 plus 2. It is also cool. Yeah, traditional way is also very good. So 4 by 4. They do say the old way is the safer way. So this is 1. So that is arrangement of this. Then look at this 1 and 1. We give me 1 divided by 2. That is 0.5. Or use the traditional method. 1 times 1 over 1 plus 1. That is 1 divided by 2, which will give me 0.5. So what I'm just trying to show you guys is then the last one, which is this and this. When it is folding, then 2 and 2, which is also going to give you the same answer as this. You have 2 times 2 over 2 plus 2, which is 4 by 4, and that is 1 ohm. So my dear students, what we are saying here is, for understanding's sake, we continue from this slide, is that after drawing the line of symmetry, I try to fold it together. Folding it together, the first 1 ohm, I have 1. So I have the equivalent resistance. I say R equivalent will now be equals to 1 plus, now they are now in series because everything here is now connected across these 2 that are also in parallel, which you've resolved to series. then it will now come and join with this one. So this is what I'm talking about. You have 1 plus 0.5 plus, I hope you can see this, 1 plus 0.5 plus 1. So what I'm trying to do now, yes, is just to add them together because they're nice series. And I'm going to have something like, this is 2.5 ohms will be the equivalent resistance of this circuit. And that will be the answer to the question. So I hope you understand this. If you have issues on that, watch the video concept on how to do stuff like this. So the next is question 7, and that is going to be on the next slide. And we have it here. Very good. Now about question 7, we have find the equivalence resistance between point A and B in the following network of resistors. I think the question is still testing us on the line of symmetry stuff. This is question 7. And don't forget, guys, the series of the electricity is in 10. We have 10 videos on electricity, all you need to know. We also have on magnetism, electromagnetic induction, and as well as atomic physics, and other part of the elementary part of physics too. So you can always get these videos on Telegram. Full videos are available on Telegram. Some of them are posted on the YouTube page, whereas some are also available on our site. Not to waste our time, my dear students, let's follow axis of symmetry and use this to get the what equivalent resistor for this question. Directly, this is point A and B. I can do it in many ways. I can connect it across here, or bringing out a line, just like what we've talked about. But I think the best way is just to bring the axis of symmetry here, line of symmetry, anyhow you know how to call it. So doing that directly, I have that. And that has been chopped off. So in the direction of line A and B, I have R and R are in series. R and R are in series. You can see A and B, R and R are in series. I'm going to have R plus R is going to give me 2R. Everybody knows that. Series is just adding them together. So R and R at the middle is going to give me 2R. Fantastic. So I have 2R at the middle. Then up here, I have 2R plus 2R. I have 4R along the axis of symmetry. Is a simple question. And the last one, I have 2R plus 2R. Here, I also have 2R plus 2R is giving me 4R as well. As you can see, all these are now connected in parallel, which you all can do. I believe you all can do this very, very well. So directly, you can just say, okay, fine. The equivalent one will now be equal. So let me do this. I just have to be careful about the capital letter and small letter. This is having capital letter. I will obscure that. And this is also having capital letter. So let's do these two capital letter first. And we have, that is 4R over 2. That is going to give me 2R. But you can also use your method. Do these two first. Then combining with the third one. You can do the 3 by saying 1 over R total equals to 1 over 4R plus 1 over 2R plus 1 over 4R. Then you go by LCM, then you follow the traditional way. It's also applicable. So, but here I can just say directly the R equivalent between point A, B is the same thing as saying I have this is a 2R, 2 big R times 2 small r. I'm dividing it from addition of 2 big R plus 2 small r. So which is the same thing as this is going to give me, this is 4RR over, you can see here, you need to be careful about this. This is a 2 big R plus 2 small r. You can reduce it from your mathematics knowledge. This is something I'm saying over 2R plus we have 1, if I go by 1 over 2R, this will give me, no, I don't want to go like that because it's going to be what? It's going to be funny. So I can leave it like this. Anyway, I can still cut because here I can factorize. I think this will be better for big R and small r. This is going to give me 2 open brackets, R plus small r. Directly, I can now say 2 can go in that. I have RR over R plus R. So I can leave the answer. It depends on how the examiner is actually dropping the answer. And this is what this is valid. This is very valid, and you can drop it like this. So that's that. And if you don't understand this, what you can do is just go by the traditional method of saying 1 over R equivalent is 1 over 4R plus 1 over 2R. This is big R plus 1 over 4R. So which is also the same thing as what I have done. So the next is question 8, my dear student. About question 8, we have something different about question 8. So question 8, we have something like this. We are also to find the what I think the same instruction goes for them because they are both points A and B. So it's just the same thing, guys. It's just to follow our axis of symmetry. And if you do that, we can quickly look into it. So let's come like this. So if we go like this, so we just have to resolve it line by line. Just follow the same principle I use in question 7, and you are going to have it. So here we can say question 8 is R and R are now in series. You can say point A and B. The middle one is going to be 2R. So everything is capital letter. So then we are going to resolve it just like what I've done. So be careful about this because I have to highlight some things here. We look carefully into this and see some stuff. Now, if I also want to connect current across A and B like this, let me show you something. So if we go like this, maybe we have a current flowing from this point like this. Then we have another one like this. So if the current is coming like this, just for understanding's sake, as it comes here, if the current is I here before, so now it has been distributed. Some are going here. We say let's say this is I1 is coming here. Then I2 is going here. Then I3 is coming here. That's another way to do that. So if you go by that, you can see here. Now, what I'm trying to say is that these and these are now flowing. You can see a branch. We have talked on how to solve something like this for the lateral form of resistor. Combine these two, look at this direct way. I'm not going to waste your time. At this point, this is R and R. 2 and R and R are connected in parallel. You know what I mean by that. Just watch and visualize everything. Parallel of this one will be R over 2. That is R times R over R plus R. That's R over 2. The same R over 2. R over 2 plus R over 2 will give you R. Please note that I'm talking about the combination of this. Everything here is going to give me nothing but R. Please keep it in mind, R. So look at the flow. The flow continues R plus this R. It continues to come like this. This is still I1. I have only resolved the one in this box. So what I'm trying to say is that these are in parallel. These are also in parallel. They are now facing each other. Then you resolve it. R and R is giving you, that is R by 2. This is R by 2. This is also R by 2. Facing each other, R by 2 will give you R. The same thing is applicable here. R by 2 will give you R if you go by the flow. So what I'm trying to say here is that here we now have R plus R plus R. It's going to give me 3R. So what I have up here is 3R. So let's be careful about what we are actually writing. 3R, which is also like this. Look at the flow here also. This is R, and R. That's also another 3R. This is another 3R. So everything is now connected in this format. So we just need to be careful when we are doing something like this. So it's very, very simple to resolve, but you just need to get the understanding. So if you have done it like this, it's now very simple to get the answer. So everything are now in parallel, which you can see. Look at it, it's continuing to flow. Oh, let me see. Look at the movement so that I don't make mistake. This is this. It will meet this. This one will come and meet this. Are they in parallel? No, they are in series. Watch. Look at the flow. I1 moves, come to terminal B. Right? This is terminal A, also move, come here. Then this one also move, and come here. So what I'm trying to say here, the diagram I have drawn here, that is what you have to understand, is very wrong because what we have should be, something like a straight line, in which the first one is the center, which is a 2 big R. The second one is coming, I think we had a R, we had 3R. And the third one is also coming. We have, that is also 3R. So now what we have between point A, B, please, this is wrong, please. It is coming like this. They are all meeting at point B. They are in parallel. My first diagram is absolutely correct. Sorry about that. Look at the flow of current. I'm taking it from point A and B. That is, am I making silly mistakes? So this is point, this is yes, this is this. The first point A and B. The second line is like this, just for you to see it. Diagram not drawn to scale, please. Then the third one is like this. So which we are now combining together, and they are in parallel. So that was what I had before. Sorry about that. The middle one is R plus R, that is 2R. The upper one is 3R. And the third one is also, here is also 3R. So guys, we can do this now. They are connected in parallel. Connect them together, and you have your combination of the resistance. So this is it, guys. And this is what I'm talking about. So guys, you can finish up this together. Let's do it together. So directly we can say 1 over R total. I can say 3R is going to give me, this is going to give me 3 over 2R. Or basically, let's use the basic way, 1 over, have 1 over R will give us 1 over 3R plus 1 over 3R plus 1 over 2R. We can write any one at any position. So SCM can be 6R. So if it is 6, can go by 6. This is 2R plus 2R plus 3R. Everything is giving me 5R. Oh, look at me. 7R. 7R by 6. So then the final answer will now be equals to, don't make mistake to reverse it. Equivalent will now be equals to 6 over 7 big R, which is the answer to this. Please keep that at the back of your mind. So answer here is 6 over 7R, and that is correct. So the next one, which will be the last question of the last slide, is going to come in a minute. We have question 9 and question 10. Very good. About question 9 and 10, directly, we can quickly do that as well. So this is going to require a bit of space. Let's try and create one, at least. So question 9 says, in a given circuit diagram, the current I1 is negative 0.3 amps, excuse me, I4 is 0.8 amps, and I5 is 0.4 amps. They are flowing as shown. The current I2, I3, and I6 are respectively dashed. Let me be quick to tell you about Kirchhoff current law, which you might have studied. I know some of you, there are some video on YouTube available on my page about Kirchhoff current and voltage law. So if you have studied that, then to use it to solve question is not that difficult. I am saying that it's not that difficult. It's what you can do. So, and if you watch, I always tell students that the direction of flow of current, if it is negative, it means it is flowing in the opposite way. So these are things you have to always keep at the back of your mind. So directly, if we go by that, question number 9, a quick one is question 9. From question 9, I3 is negative 0.1. Look at the direction of, I said I3, I1. Look at the direction of I1, it's coming down. So because it is negative, that means the direction is this 0.3 ampere. Negative means the flow is now not in this direction. It will be in opposite direction. So keep that at the back of your mind. It's coming here, 0.3 is still moving here. So we need not to make mistake. So let's see another parameter that was given. We are given I4 to be 0.8. You can see I4 is here, 0.8. This is 0.8. So moving in that direction, you can see 0.8 amps is coming like this. The same thing will flow here. So we just need to be careful. I5 is 0.4. I love that. So if I5 is 0.4, that means there is a bridge. You just need to be careful.
So if current that is flowing from here, now you can see this is 0.8 amps, and the one coming here is 0.4. That means it has been divided. That means 0.8 minus 0.4. So that means 0.4 will enter here. Then the 0.4 will continue to move here. So be careful about all these in place. 0.4 will come to this place. So my point here, guys, to solve that question is just to know how you want to distribute the charge. So that is just what you need. So let's be careful about this. I5 was said to be 0.4. Look at the direction of 0.4. So here is 0.8. So 0.8 is supposed to be moving along this. So we just need to be careful about that, because the question asks us to find I2, I3, and whatever. I2, I3, I2, this is 0.4 is I3. I2 is also the same thing as I3. You can see the flow, it will continue. What I did here is 0.8 is coming, given as it reaches here, 0.8 is supposed to be flowing, but something happened, only 0.4 was moving here. So what happened here is that 0.4 of this has come through this, and it's coming like this, and it's coming. So I can say directly that I3, I2 is equals to I3, which is equals to 0.4 amps. Just need to be careful. Then the last one we're looking for is I6. About I6, let's see the flow. 0.4 is coming here. 0.3 is coming here. Let us be guided. Let us be guided so that we don't make mistake. The total current here is 0.8. Sorry about that. I5 is 0.4. Fine. 0.4 enters here. So the total current that is coming here is 0.8, please. So 0.8 is moving, and it continues to move until it reaches, you can see 0.3 is coming backward. The total number is now 0.8 plus is 0.3, which is something as of 1.1 ampere. So these are the valid answers to the question. So please, it's a very simple question. It's just to know the direction of flow. I4 is 0.8. 0.8 is coming. 0.8 will continue to flow. Only 0.4 was in I5. So, but the total distance here is still 0.8. Never make that mistake. Only 0.4 was here. That is why 0.4 of it is coming inside. 0.4 of it is continuing to flow. So the total amount of this here is 0.8, which is 0.8 here. So 0.8 plus this is what gave me 1.1. So we need not to make mistake when we are dealing with questions. And you know, I3 is also going to flow into I2, which is what you can see. So be careful about that. And that is that. So the next one, which is the last question, is question number 10. Question number 10 says, find the current through I2, okay, in the 12 ohm resistor in the figure. Fine. So I think this is just basically on Kirchhoff current law. I told you about the loops and junction. So we just need to know the node. So here, where everything is meeting, no need to disturb ourselves. So what the law states that this is where they are meeting. So I'm going to say, let the current that is entering this point, I take it as X, which is what we need to know how to use. V is equals to IR. So I'm using Kirchhoff current law. I make I a formula, it will be equals to V divided by R. So I'm going to distribute that in all the circuits and use it to solve the question as though they were. So directly, my dear student, what we are going to have here is I will take it one by one. We know I is V by R. Here, look at this. I am moving towards X. So here I said, you can see 11 volts is moving here. So 11 minus X is the potential at that point. Now, another thing is, let's try to indicate the direction. This one is moving in, others are moving out. The law states that the sum of incoming is also equal to the sum of outgoing. So incoming, outgoing. Incoming is this one. So I can just say I1, I just call incoming I1. And the other ones are moving out, I call it I2, I3, and I4. So directly we can now use I is V by R. The first one is V by R. At this junction, you have X, 11 minus X. We are dividing the value by the resistance, was 12, must be equals to I2. I can take anyone to be 2. X is the one moving in. So X minus the voltage here is 2. I'm dividing that one by 6. I'm using V by R, which has been shown on top of your screen. You can always look into that. Then you have a plus I3 here. I can take the one straight. So that is X is also moving there. X minus 3 divided by 4. And the last one coming down, the one coming down like this, we said plus X is also going down. X minus 4. We divide that one by 8. So the rest is just, you can do it anyhow you know how to do it. I can go by LCM of this. I think the best LCM for this is 24. So multiplying 2 by 24, you can go for LCM your way. 12 times 2 are 24. 2 here, 11 minus X is going to give me the same 6 times 4, X minus 2. I hope you can do this. Then plus 4 times 6, X minus 3. Then plus 3 into bracket X minus 4. So you can cancel whatever you want to cancel out by removing the bracket. Expanding that, you have 22 minus 2X is equals to 4X minus 8. You have plus 6X minus 18 plus 3X minus 12. Collect your like times. 4X plus 6X are 10X. 10X plus 3X are 13X. We have this is minus 30 minus 38 is equals to 22 minus 2X. So directly here you can say you have the same thing as saying we have 22 plus 38. I move 38 to the LHS. I have is equals to 13X plus 2X. So directly 22 plus 38 is going to give me 60. Is equals to 15X. And X directly will be 60 divided by 15, and which is going to give me X is equals to 4. So 4 amps stands for the amount of current that is flowing at that X junction. Remember the question called for the one that flowed through 12 ohm resistor. Around 12 ohm resistor, this is a 12 ohm is, I have I equals to, look at this, current in 12 ohm resistor is therefore, directly we can say I is equals to V. The voltage across 12 ohm resistor is 11 minus X. 11 minus 4 divided by 12. The rest is what we can finish. 11 minus 12 is 7. 7 over 12 amps is correct to that question. And that is the answer to the question. So guys, that is where I will be stopping. See you guys soon in my next video. Thanks for joining and hope to see you soon. Bye for now.